Hey everyone, good afternoon. I'm just letting everyone in here. After I stop getting notifications, we'll be jumping into our check-in question. The check-in question usually serves to help me double check on attendance. It also serves to help to get to know you better as well, even if it's virtually. The hope is, of course, that we do meet each other in the future. But welcome everyone. We're in pre-calc period 6. It is September 21st. We have about maybe half the class here as I'm letting everyone in. All right, let's go ahead and get into that check-in question so that um, go ahead and double check the attendance. All right, sorry, that's weird. Not the agenda. Here's our check-in question, everyone. So in the chat, go ahead and put what was your favorite childhood cartoon show? Go ahead and use the chat for that. So this is again your favorite childhood cartoon show, like when you were a kid. What did you watch? All right, we got some Tom and Jerry. I also watched that too. All right, let's keep it going, everyone. All right, SpongeBob, yeah. Ben 10, don't know what that is. Adventure Time, SpongeBob, yep. Courage the Cowardly Dog's a good one. Heck of SpongeBob, a lot of SpongeBob watchers. Gravity Falls, Steven Universe, or Pokemon, can't decide. Ooh, yeah, I used to watch Pokemon when I was younger. Back before it got all complex, it was just the first season. Flapjack, Dragon Ball, Rugrats, OG Teen Titans, or The Kids Next Door, Courage the Cowardly Dog. Yeah, Tom and Jerry. That's a classic. That's okay if you didn't have one. My younger sister watched that, I think. Codename Kids Next Door. Yeah, and a bunch of SpongeBob fans. Awesome. Thank you all for sharing. So let me go ahead and read to you who I don't have. Um, so I don't have, and again, if you're friends with them, if you can send them a text so that they're not marked absent, we're in our second week of the module. So like we're kind of partway there. And then we have next week and a few days after that. Okay, so I'm missing Jalen Baker, Gabriel Campuzano, Rebecca, Carlos, Kyla, and Ryan Williams. If y'all have their number, if you could let them know to come on in. So again, it's Jalen Baker, Gabriel Campuzano, Rebecca, Carlos, Kyla, and Ryan. We got Gabriel. Cool. So I'm gonna go ahead and enter the attendance here on Power School, and then we're gonna jump into the agenda. So let me just go back on my slide so y'all can take a look at what we're gonna be doing here today. I'm gonna also talk a little bit about asynchronous number 2 as well. I know there's a little bit of a weird thing that happened there. I'll talk a little bit about that, but go ahead and read that as I enter in the attendance. So we don't have Jalen Baker. Oh, I'm sorry. We're also missing Jirel. So if y'all friends with Jirel, we have Carlos, Kyla, and Brian. Oh, we got Ryan, y'all. All right. Yeah, so let me answer some of those questions in a second. So welcome to those who just came on in. We did have our check-in question, but who I have marked absent right now, it's Jalen Baker, Jirel, Carlos, Kyla, and that's it. That's who I have absent right now. I just got you if you just came in. Okay, so let's go ahead and talk about that. Yeah, so some of you are asking some questions about late work and so forth. I'll answer some of those in a bit. Let me first go over the agenda and then I'll answer that. So we had our check-in and attendance. We're gonna be finishing the average rate of change notes. So remember last week on Thursday, we kind of had an introduction on what the average rate of change was. And we did that by measuring heartbeats per minute. So measuring beats per minute, that's an average rate of change. And on your asynchronous assignment number 2, you were able to find average rates of change, but with graphs and with functions. After we go ahead and finish up our average rate of change notes, we're gonna start another lesson called equivalent expressions. And then at the end of class, we're gonna review what to do and so forth if there's time. So Asynchronous number two. So for some reason, when I created the assignment on Google Classroom, I attached it, but for some reason it didn't load. I don't know if that was a Wi-Fi thing because I've been having drops in my Wi-Fi for some reason in the weekend. Don't know why. Even like when I watch Netflix and so it starts loading. So there was an issue with that. So I know yesterday in the morning I went ahead and I attached the assignment. And what I did is I extended it to be due today at 11. So asynchronous was due today before asynchronous number two was due today before class. And again, asynchronous number two kind of, I have a video on there where I talk about how to do average rates of change with graphs and functions. And as a heads up, async number three is posted and that's due tomorrow, Tuesday at 11:59 p.m. Now, if you pay attention in class today, asynchronous number three will be a breeze because we're going to do something similar today in class. So this would be a breeze. If you pay attention, you can even start it right after class is done. Okay, so now to answer the questions in the chat about any late work. So someone said, can I turn in async a little late? I mean, as long as you're reaching out to me and coming into communication, of course, you don't want to let your work pile up. How it works for my class is I usually accept the work within a week. So as long as it's within the week, you get it into me, you come into contact with me is what I'm expecting. So you could text me on Remind, let me know what's going on, and I'm happy to accommodate for you. So that's what my policy is for late work. So yeah, if something comes up at home, you're not able to get it in, communicate with me. But if you're not communicating with me, I'm gonna just enter the grades and it's gonna show up as an NC or something like that. Uh, Communication is key. And then it says, I turned in last week one late. Is that okay? Like I said, text me, let me know, because I actually don't get notifications about Google Classroom. So I don't get notifications if someone's turning in something late. So you're going to have to text me and remind or send me an email like, hey, can you grade this? Can you check on this? And I'll do that. Also, use office hours too. That's another good tip. All right, so does anyone have any other questions on that, on async number two, or anything about async number three? Today in the evening, I'm gonna go ahead and take a look at your work. Yeah, I don't know why, I know I just got you back in, Daniel. I don't know why you're kicked, but you're back in. I'm gonna be grading and taking a look at asynchronous number two. One thing I wanna point out is I might return your work back to you if you're missing work. That means you're not showing how you got your answers. I'm going to give it back and I'm gonna say, please show your work. I'm gonna give you another opportunity to get that in with your work fully shown. So just a heads up on that when I take a look at that later in the evening tonight. All right, y'all, let's jump into what we gotta do today. So we do need some notes. We do need a pencil, pen, whatever you got. Remember, sometimes I do collect notes. I might or might not today. So just be on, gotta take your notes today. We already did this check-in. Notes out and ready, everyone. Yeah, you can take your notes on the computer, totally fine. Always is fine. You could do computer notes or paper notes, whichever. Yeah, I got both submissions the other time. All right. I hope your notes are out and ready so we could start our notes on continuing our discussion on average rates of change, everyone. All right, let's go. Oh yeah, by the way, I totally stole this image off the internet. It's a free image though, so it's not really stealing. Okay, so the definition of the average rate of change. Oh, okay. Sorry, I did that in caps. That was not meant to be in caps, and I was replying to a private chat. All right, y'all, so the definition of the average rate of change, let's write this down. So again, we started off talking about the average rate of change when we did the beats per minute, and y'all figured out how to do that. We did total beats over total minutes. So rates like that one are used to describe how one quantity is changing in relation to another. Again, that's beats per minute. Whenever you have a per there, you got a rate. But if you have a function like you did in asynchronous number 2, the rate of change is usually defined as the change in y, the dependent variable, divided by the change in x, the independent variable, for two distinct points on the graph. So that's if you have a function. So we're trying to move from, the heartbeats and the way y'all worked on it in your head to now moving into the how you would do it on a function or a graph, which is change in y over change in x. That's the average rate of change when you have a function. And again, this is familiar. It should sound familiar because change in y, the triangle means change, over change in x. That's basically the slope formula, right? Remember, m equals y2 minus y1 all over x2 minus x1. That's basically what the average rate of change is. You have your 2 points, you take them, you plug them in, you get your slope. But in this case, we're going to get an average rate of change. We don't really want to call it slope because you can find the average rate of change for any function, even a curvy function that's not a line, because we say slope for lines only. So this right here, this formula tells us the average rate of change for any function. And again, you could write this as y2 minus y1 all over x2 minus x1. You know what x2 and x1 and y2 and y1 is because when you have your 2 points, you label them. I went over how to do this in asynchronous assignment number 2. So you want to make sure you look back on that if you haven't yet. Yeah, you want to write this down. Yes, please write this down. Okay. I'm going to move on in a second, everyone. I'm just taking care of some private chat questions. Okay. So let me go ahead. Oh, okay. So let me go ahead and give you all like 20 more seconds or so on this slide. Let me give 30 seconds for y'all to get this down, and then we're going to move on to an example problem. Now this example problem that I'm going to move us on into, again, it's going to help you for asynchronous number 3. And I'll be modeling for you what it looks like, to show your work, what I want to see when you do your asynchronous number 3. So a few more seconds on this slide. Yes, these slides will be posted. So yeah, thank you for that reminder, Rosario. I will have these, sorry, that was a private thing. So I will have these slides posted. Thank you for that. These will be posted and these should actually have all the slides for this module for this unit. Yes, I'll be posting this after the class today. So you'll have access to this in case you miss something. All right, y'all. Let's move on to the problem. So again, this is the major example. Let's do an example of a problem. So we're gonna have to write down this problem here. First, write it down and then I'm gonna talk about it. So here is the problem. Notice there's no question associated with it. It's just basically a situation right now. I'm gonna first read it, and then I'll leave it here for a bit so y'all can copy it down. So basically the scenario is a child is throwing a tennis ball into the air and it lands into the mud. The function, this function right here, h of t equals negative 16t squared plus 16t plus 4 gives you the ball's height in feet with respect to time in seconds. So go ahead and copy that down, 30 seconds or so. And then we're gonna, you wanna write this down. This is the problem you wanna write down. Again, and it's gonna show up in your next asynchronous assignments. I would write down the whole situation or just, major parts of the situation, not just the function. Is it's important to know that a child is throwing the ball and so forth. Let me go ahead and give more time, 30 more seconds. And we're gonna be doing some stuff with this problem for a bit before moving on. So make sure you got this down. Again, the slides will be posted though, just in case. All right. So don't worry if you're still copying this down, because in the next slide, we have the problem up here, okay? So don't worry about it. Just go ahead and continue to look up here. But what I'm gonna do next is we're gonna copy down some stuff. So basically, whenever you have a situation like a word problem or something, it's always good to model the situation. And what I mean by modeling it is creating a visual for the movement. Usually in math, that means you either graph it by paper, so you're gonna do an input-output table, you graph it on paper, or you could use Desmos as well. What I did is, for me, it was easier to just go on into Desmos, create a model of the situation. So there's the model. You could go ahead and sketch that model out. And I also want you to notice that some of the points here, like for example, this point right here, we want to be able to interpret each point. So it says that the T right here is time in seconds, and the ball's height in feet is basically the H or the Y. So this is height up here, H, and then this is feet in seconds. Sorry, this is just seconds. This is height in feet. This is height, and it's feet. Always label your models. So basically, instead of X comma Y, this is going to be S comma H. So this is seconds, and this is height. So basically what this is saying is that negative this many seconds, let me undo that, negative this many seconds, we have a height of 0. I'm going to go ahead and ask everyone to use the chat, or some of us to use the chat. Now, does that first coordinate point I just talked about make sense? That negative 0.207 seconds, I have a height of 0. Does that make sense? And I'm asking this towards the chat. So I got some no's. And then we got a little bit no. Now, for those who are saying no, I'd like to know why it doesn't make sense, though. Like, what about this coordinate point that I talked about, the first one, what about it does not make sense? Yeah, thank you, Miles the God. You cannot have negative time. So basically, when you're looking at a model, you want to make sure that you identify, and how we say this, identify the appropriate domain. So what domain makes sense? Remember, all domain means what input makes sense. So basically, and then we had a question that Danielle put, doesn't it mean before doing it, it does go up, doesn't go up? Well, that's true. But in the end, maybe the child did not even pick it up at that supposed negative time. So we can't really make any like inferences about that. So what we have to do for this to make sure it makes sense in the real world is you have to adjust your domain. So that means basically every part of this graph that's over here to the basically the left of the y-axis does not make sense. It does not make sense on this side because the time is negative, so I'm just taking it out. What I'm doing right here is I'm adjusting the domain. Let me type that out. So I'm trying to change my function so it makes sense. Change where I'm looking at in the function. To make real world sense. Right, so again, because the time can't be negative, I am taking out these portions of the graph. There's more parts of the graph we need to take out. Does anyone know where else I wouldn't make sense at all in this graph?
Going more down?
Going more down, be a little bit more specific, because it goes down a lot of spots. Like here it goes down, right? But these points make sense because
Oh, I'm just talking about like when it dips below 0, but I don't think you're talking about that.
like here, like when it goes down here below 0.
Yeah.
Yeah, to be honest, you're good. So why would it not make sense here as well, below 0?
Because it can't go underground.
Because it can't go underground, yes. And also you're gonna end up with a negative height down here, For example, I don't know, this could be something. I just know that, like, sure, the time will be positive, like the seconds will be good, time is good, but then it's going to be after you hit a height of 0, you're going to get like a negative, I don't know, let's say -1 feet, which wouldn't make sense as well. So that's correct. Anything below here also does not make sense. So I'm going to adjust my domain. So the part that does make sense is all the stuff from here, 0,4, all the way until it hits the ground. That's right. And I did not see who was talking at that, but props. That was good. Props, yeah. So that's what I mean by adjusting the domain. It means taking out parts that don't make sense, and you're looking at the parts that do make sense. Awesome, y'all. So here's the next thing I need you to do. Let's go ahead and copy down this table. So usually what you'd have to do is you'd have to take the inputs, plug the function. For example, my first point is 0. That means I'm going to plug in 0 for this t and for this t so I could get my output in feet. And or, right, you could use your graph. If you have your Desmos open, you could totally use your graph to fill in this table. When t equals 0 time, how you would plug it into the function is you do this, and you'd evaluate, you'd get an output of 4. And again, notice how that makes sense, because my first point right here, when t equals 0 seconds, I get an output of 4 feet. The ball is at 4 feet. So basically the kid's hand looks like it's 4 feet. Or maybe the kid is 4 feet high and throws it, lets go of it, and he's like really short. So that's where it starts. The next point, we're gonna do 0.25. I'm just modeling for you how we would do this, right? Because in your homework, you're gonna be filling out a table too. So you wanna show your work similarly to how I'm showing it right here. Now for this one down here, we wanna be careful because you need to use PEMDAS. A common mistake I'm noticing is people like to multiply these two first, like they do -16 times 0.25 and then they square it. No. So you got to do PEMDAS. What that means is, and let me undo that, you got to do the exponent first. So you have to do 0.25 squared. That means 0.25 times 0.25. Then after you do that, you can multiply it by the -16. So be careful. PEMDAS always. Exponents is first. So if you do that accurately, you'd get this. Notice how right here is when I did the parentheses first. When I did 0.25 squared, I got 0.0625. And then when I went ahead and put that into a calculator and evaluated, I got 7. Sorry, it's behind my little words right here, but we got 7. So then in my table, I'm gonna go ahead and put 7. Now, I went ahead and I just modeled for you the work that it would look like, right? If I was to evaluate the function. I'm gonna go ahead and just fill in the rest of it for us now that you know how to now that you got some samples of how to do it. I'm not gonna sit here and we're gonna do every single one. But of course you wanna double check my work. Let's fill in the rest of this table. So again, you wanna do your own work when you're doing your homework. I just did 2 samples for you there. And again, notice that right here we have our negative heights. These are the parts where it doesn't make sense, right? These are the parts that we don't need to care to look at, but they're there. So again, negative heights doesn't make sense. Negative heights. No sense. It's hard to type. I mean, it's hard to write letters here. Or I could have used the typer. There we go. So first I'm gonna go ahead and pause it here. So what I did right now is we have this problem. We created a model for the situation. We also adjusted the model, right? We took out the parts that didn't make sense. So we have the real scenario of what happened. Next, I had you all fill out this table and I showed you all how to show your work when you're plugging in and substituting into the function if you're trying to fill out a table. You will be asked to do that in your next asynchronous assignment. So that's just an overview of what I did right now. We're going to still continue to work on this problem, but let me give you all a few more seconds to get this down in your notes. And then again, any questions, feel free. You could do it privately or towards the group. All right, y'all, we're gonna go ahead and move on from this slide unless anyone needs to really get something down. And then by the way, y'all, just if you need a recording of any of these, just let me know. I'm happy to also send it to you as well. It takes a bit to download, but yeah. Let me know if Kyla is here, by the way. I thought I saw Kyla, but I'm not sure. So I could adjust the attendance. Okay. All right, y'all, so let's keep going. All right, so we created a table, we have this graph, cool. So we're gonna still work on this function because that's not the main thing that we're trying to do. The main thing is we're trying to find actually average rates of change, which is this right here. So we're gonna be using the table to determine the ball's average velocity in feet per second for every 0.25 second time interval. So don't be afraid of the language here. So average velocity, I'm going to underline that word. And its units are feet per second. And they want us to do it for every 0.25 second interval. So I'm not gonna do it for every 0.25. What they're saying is every 0.25 seconds, like this. That would give us how many calculations? I'm only gonna do like 3. It would be 1, 2, 3, 4, 5, 6. Yeah, we're not gonna be doing 6. I'm only gonna do a few because we don't, have to do every single one to get the point of it. Just like 2 to 3, and then we'll stop. So average velocity, that's very similar to average beats per minute. What you're gonna have is a change like total something over the total time. So the total something here is going to be the height, or the total change in height over time is gonna be the average velocity here. And again, the units for that are feet per second. That's because on the top usually goes the height and at the bottom goes the feet. This is like the change in y over the change in x. It's always like that. Y is always on top for these problems. So let's do it for the first one. So between 0 and 0.25 seconds, we're going to go ahead and set up the formula for average velocity. It's distance over time, or the change in distance over time, but we could think of it as the change in y over the change in x, the same way y'all did it in the homework. So for this problem, change in y is like your change in h, and then over the change in x is like the change in the t. So how we're going to do this is on the top, notice how I set it up, everyone. I did 7 minus 4. That's the change in height. It went from 4 feet to 7 feet. So it's going to be 7 minus 4 feet. And at the bottom, I have the change in time, which is 0.25 seconds minus 0 seconds is just 0.25 seconds. So that's all I did. Again, another way to think of it is all we did is change in y over change in x, which is basically the slope formula. So 7 minus 4 feet, that's going to be 3 feet, divided by 0.25 seconds. All right, this is when you could pop out a calculator, or if you could do the math mentally, 3 divided by 0.25 is going to be 12. And then your units is going to be feet per second. So when the kid threw the ball, it was going really fast. Like at first, when the kid threw the ball, it's going at a rate of 12 feet per second. It's going at a fast velocity because he just threw it. Now, I expect, right, after the ball's in the air, that over time it will slow down, right? After you throw a ball, it slows down and it goes to the ground. So we shouldn't expect the ball to speed up while it's in the air. Now, that would be really creepy, right? Because air needs to be pushing it back and it should slow down. So I'm going to test that. So we're going to do the next one. So I should expect that the next 0.25 seconds, which will be this one right here. So the next round right here, I expect this, the ball to go slower in the next 0.25 seconds. Let's see, there's something in the chat. So for 0.25 to 0.5, you would do 8 minus 7. Yes, you're correct. That was a private chat, everybody. So for this one, right, we're going to do between these 2 points right here where my mouse is at, we're going to do the change in y. So the change in y is 8 minus 7. Oops. And all over the change in x. So it's going to be 0.5 minus 0.25. See right there, there's my setup. 8 minus 7 feet all over the change in time, which is 0.5 minus 0.25 seconds. 8 minus 7 is positive 1, and 0.5 minus 0.25 is just 0.25 seconds. 1 divided by 0.25, 4 feet per second. And again, you would use your calculator for that. Yes. Then Daniel, you already tried it, you got 4. So notice, when the kid threw the ball, it was going at a fast speed. Velocity is another way of saying speed, by the way. So it was going 12 feet per second, and over time, because the wind, right, it's going to slow down the ball. It slows down to 4 feet per second. And then you should expect it to keep slowing down and also becoming negative when it's sloping downward as well. All right, so for the next one, for 0.5 to 0.25, let me go ahead and clear my drawings on the top here with my eraser. Yeah. So for the next one, I kind of wanted you all to do it like on your own without me writing it. So I would like you to find the average velocity of these two from 0.5 to 0.75. Go ahead and try it out on your own. And let's see what you get. Let me give you all about a minute. Try out the last one and see what you get. And or feel free to also ask me questions if you're stuck on anything. I'll give you all about a minute. Okay, so we have that this doesn't make sense. Go ahead and ask some clarifying questions. I'm happy to, help out. And then feel free to also ask clarifying questions privately as well. If just in case you don't want any, or you could unmute yourself, whichever way, best way to do it. But basically what we're doing here, for Ryan, as far as your question went, okay, like all the way of it, how it's described confused me. So let me know if anyone, how about if someone in the chat is able to kind of write down what I'm doing here, please, to translate it for us. But I'll go ahead and go over it again, Ryan, just an overview of what I did. Okay, so here in the chat, a few of you are telling me you got -4 for the last calculation. Let's see what I get. Yeah, the answer is -4 feet per second. Now, does anyone need me to demonstrate how we got -4? I wonder if it would help. Okay, a bunch of us got -4. Would it help, Ryan, if I kind of wrote down how we got -4 for that last one?
Yeah.
Okay, awesome. Let me go ahead and just clear all these drawings so that it makes it easier to see. Okay. All right, how do we get -4? Let me just go back. There we go. Okay, so step 1. These right here are given to you. See, notice how these in blue, they're like the first 0.25 seconds, then the next 0.25 seconds, and then there's the third 0.25 seconds. This I'm giving to you. I'm just asking you, hey, find the velocity between those time zones. So this right here is not something you come up with, just to clarify. This, I'm giving it to you. So that's the first thing. So then, okay, if it's telling me to look at these seconds, here's my seconds and time. So I'm looking at this one, 0.25 seconds, to 0.75 seconds. So that means these are my points. So if you were to write that in coordinate point format, like, you know, let's say you're used to seeing it like x comma y, it would be 0.5 comma 8. And then my next point would be 0.75 comma 7.
Okay, I think I understand.
Are you sure? You don't want me
Somewhat. But
to... Okay, I can keep going. But once you have it set up like this, you could label your points. So you could do x1, y1, x2, then y2. Then all you do from there is you're going to plug it into the slope formula. And remember, the slope formula is the y2 minus y1 all over x2 minus x1. Basically, what you're doing here is finding slopes. It's like that. The slope is telling you the velocity of the ball. So I'm going to go ahead and plug in the points. So y2 minus y1, that's 7 minus 8 on the top of your fraction, divided by, then you have 0.75 minus 0.5. Ryan, what's 0.75 minus 0.5? Sorry, yeah, what's 0.75 minus 0.5? If you could answer or use a calculator for it. It's really messy, but.
wait, what was it?
What's this part right here? 0.75 minus 0.5 at the bottom. You could use a calculator.
Is it 0.25? 0.25?
Okay, let's see. Is it? Shoot, I'm gonna use a calculator. Yes, you are correct, my friend. 0.25. Oops, it's messy, but what's 7 minus 8?
1.
Yes, except the sign. Be careful about the sign. You're almost there. I mean, it's 1, but it's going to be, change the sign of it.
-1, my bad.
Perfect.
Negative.
Wait, did y'all get something? Wait, the chat is bouncing up. Oh, you don't all have to answer. I mean, that's okay. Sorry, y'all. I wasn't paying attention to the chat. So at the top, yeah, -1. 7 minus 8 is -1. And then you do -1 divided by 0.25. And if you do that in a calculator there, you'll get -4 and then feet per second.
Okay, I understand it now. I get it.
Yeah, because then that if you know how to do this, the next asynchronous is going to be it's going to be a breeze. Thank you for the question, Jaws. I'm always happy to stop and walk us through it. Wait, you said no, I got -1. Oh, were you talking about the previous thing, Daniel? Yes, -4. Yes. Yeah. So -1 divided by 0.25 in the end gives you -4 feet per second. So that's how we got that answer for the last one. And again, I rewrote it like this in case it was easier for some of you to just use the slope formula. Just do the change in y over change in x, because that's basically your velocity. All right, y'all, let me know if anyone has more questions on this part. If not, we're gonna go ahead and move on. Great, let's go. Let me clear up my drawings. And again, if anyone wants a copy of the video, feel free. So I could go ahead and download it. All right, everyone, we're going to be doing an independent then group activity, and it's going to be really short. We're going to go until the end of class for this one. It's in the last 15 or last 13 minutes here. Okay, so how this is going to work is I'm going to be giving you 4 expressions, and I want you to match them up because 2 of them, because they're equivalent. You just need to match them up, if that makes sense. I'm going to show you what it looks like. After that, you're going to be put into groups like we did with the heartbeat time. You're going to be asked to come up with reasons and justifications as to why your group matched up each card. And make sure that you include the why, like we multiplied or we canceled, we combined like terms, whatever it is you did, just describe it. And how it's going to be a Desmos activity though. Once you're grouped, only one person for the group will sign in and put everyone's name. And I should see you screen sharing the Desmos if I pop into your group. So the Desmos activity is on, it's on Google Classroom. So not right now, but once I move you into your groups, one person from your group needs to log in and put everyone's name, right? That's how I'm gonna be giving credit for this. So it's on here. Once I break you up into groups, your next step is choose one person. Y'all can choose whoever has like the birthday coming up or something can do it. The one who's gonna log in and share your screen. You're gonna put everyone's name because what I should see is about 7 groups because we're gonna have about 4 people per group. And then you're gonna log in 1 per group. Not every single person is gonna log in, if that makes sense. Does anyone have any questions about my directions right now before I put you into groups? Let's see the chat. Do you have the notes things up where we turn them in? So actually today, notes won't be collected. So I'll let you all know when notes are collected. It's usually I'll let you know at the end because if I say notes aren't being collected, sometimes we don't take notes. So today, notes will not be collected, y'all. But great job if you took notes. I bet they look really great. But other than that, does anyone have any clarifications about my instructions right now for the group stuff? So once you're in your group, only one person is going to log into the Desmos. You're going to share your screen so that you all can work on it. If no one has any questions on that, I'm going to go ahead and start making the groups. And after that, I should see you all going on to one Desmos and from there working on the activity. All right, y'all. Let me stop sharing so I can make the groups. And then again, if there's any confusion, I'll be in the group so I could, you know, help you out if anyone's stuck. Okay, so let's see. All right, everybody, you should be receiving an invite. Go ahead and click yes, join. Make sure everyone join your group. You should get an invite that says join. Make sure everyone joins your group. CJ, Risha, did y'all get an invite? Hey, CJ.
Yeah, I got kicked. I don't know what happened.
Oh, okay, no wonder that's okay. Let me move you into a group. Go ahead and see if you could join the group. Do you see an invite? Okay. Cool. Risha, are you able to see an invite?
I have no idea.
Big Nanny. She walks in.
Hey,
She walks in while I'm greeting.
anyone have any questions? Yeah, so choose one person here. Maybe whoever has a birthday, the soonest birthday, whoever's oldest. How about
I
you?
think Zion's doing it right now.
I'm already doing it.
Oh, we're
Yeah.
doing it. Okay, cool. And then just make sure, share the screen, complete the activity the best you can. Just jumping in here, and that's hilarious. Y'all are talking about what if I come in. All right, y'all. I'll be back in a bit.
All right.
And
Oh.
I'm gonna like make this shit.
Hi,
and I
miss.
think
hello. Does everyone get what we're doing right now? Just double checking.
I don't, but I think Rosario's explaining it to me.
Okay,
are
perfect.
we just supposed? Isn't it just supposed to be like one person who like turns it in for the whole group?
That's correct. And whoever that one person is, like sharing the screen so that everyone can see what they're writing and all that helps.
And what are we solving?
It's all on the Desmos. You're gonna take a look there. You're gonna be basically matching up some cards is what's gonna be happening.
Oh, okay.
Perfect. All right, I'm gonna bounce out to see other groups.
Oh, great. Your job is to make sure writing the group's ideas, pick the person's name. Oh, that's me. I'm closest to Z.
Hi y'all. Does this group know what's going on? Just checking in. Hello. Sam, Denise, Gerard.
I'm confused a little.
Okay. Confused a little. Does everyone? Okay, so one person from this group should be going to the Desmos activity. You just want to do one per group, and you should be filling that out. So maybe we could do whoever's the oldest could do that, and then share your screen. Maybe everyone could say their names. I mean, sorry, say their ages, and we could go from there.
17.
Okay, we got 17 for Denise, 16 for Sam,
16.
and then 16 for Gerardo. So the oldest. So who's older? Oh, sorry, Denise. It looks like you're the oldest one. So what you want to do is you're gonna go to Google Classroom, and on there is a Desmos activity. Once you have that open, you're going to click that green thing that says share your screen at the bottom. Are you able to do that? Or
Yes, I'm doing it right now.
perfect. All right, cool. All right, I'll be back. Just gonna check in on other rooms. Hi, how's this group doing? Does everyone?
Yeah. Right now, I guess we gotta focus on which roles everybody's about to take.
Okay. So do we have the Desmos open?
I do, but I have to do everything from my phone because my computer's not working.
Oh no. I wonder if maybe someone else who has it on their computer can do it so that way we can share the screen. Are you already logged into it, CJ?
Yes, but since I haven't finished like all the questions, I think somebody else can still be able to do it.
Okay. So maybe either Jasmine or Tori, if y'all want to go ahead and open up the Desmos for the group. We have a bit of 4 more minutes or so on this. I definitely want you guys to take a look at the sort at least before this activity ends, and if y'all can share the screen. So anyone can go. Awesome. Perfect. And if y'all can just skip the first portion and just jump to the part where you're matching up the cards, that would be great. All right, y'all, be coming back in a bit. Hi, how's this group doing? How's this group doing? Marcella, Brandon, Leon.
Hello.
Hi, where's everyone at in this group?
Oh no.
Don't know? Okay. Cool. So there was some directions. So you wanted to, one person, whoever's the oldest, should be going to Google Classroom and opening up the Desmos. Now, because of the timing, we have like a little bit of 3 minutes left. Now, I don't know if these groups can be saved or not, but that was the directions. You want to go ahead and go into the Desmos, but I'm gonna see what we do right now, right? Because it was a little bit confusing, so some groups were a little lost on how to get started. So I'm gonna bring everyone back in a second, all right?
All right.
All right, I'll be back though.
Timekeeper. Alex, you're team captain.
Captain, but it's G.
I submitted. Oh, no. All right. Match the equivalent equations after discussing with your group. Wait, can you see the screen, right?
Mm-hmm.
Okay.
I think 2 and 3. Wait, match them how? Wait, match the equivalent equation.
I don't.
Let me see.
Do we like? Oh, okay, I see how to match them.
All right.
Yeah.
Hey, Risha, I got your message. I'm gonna go ahead and bring everyone back right now. I'm closing all rooms. Hi, everyone. Welcome back. Welcome back. Welcome back, everybody. We have about 19 of us back. All right, so let me go ahead and talk about what we're gonna do. So a lot of groups were able to look at the sort, yeah, and some were barely gonna get started. So here's what happened. I kind of randomized the groups, but I wanna kind of keep the same groups for when we come back to this activity. You know, it's not like a lost cause and you could log back in, whoever it was that's in charge of logging back in. So I went ahead and I took pictures of who was in each group so I could reassign you back into the group when we come back into class on Wednesday. So we're gonna go ahead and continue this activity on Wednesday. Hopefully all the issues are solved by then and we all understand what we should be doing. Now, if you have an issue with the original group you were in, just let me know, text me so I can make some adjustments, okay? Let me know and reminder. So if you work better with, if you have any beef with someone, whatever, just let me know and I'll make some adjustments. But otherwise, we'll be keeping the same groups for Wednesday, all right, everyone? Please make sure you get onto those asynchronous stuff. We have the next one due Tuesday. Other than that, y'all, I hope y'all have a great day.
All right. Bye
I'm
then.
gonna head out.
Everybody,
Be safe.
Wait, hold up. Wait, hold up. Miss
yeah,
Miss,
go ahead.
Donna. Oh, okay. So do we just log out of Desmos for now, and we'll have everything saved?
Yes, as long as you log back into it, that's correct.
All right.
Yes.
All right, then.
All right, bye y'all. And
All right.
Risha, are you still here? Okay, let me see.
Yeah.
Oh, because you were kind of booted out before that, you weren't grouped. Let me see, it's whatever group has 3 people in it. So let me just see. Let me go ahead and message you. And then you could let me know if that's okay.
Okay. Was there anything I missed because
No, not really, except for it was mostly we tried to start on the activity, but we didn't get to. So this is, check it out. I sent it to you in the private chat.
Yeah, it's fine.
Is that okay?
Thank
Okay.
you.
Yep. All right. I'll see you next time.
Okay, bye.
Bye. And hey, Denise. Go
Hi, I
ahead.
don't know if you got my question in the chat.
No, my bad. What'd you say?
So, like, they weren't talking, so I wasn't really able to interact, and like, I already didn't really understand what was going on. Like, I really don't like using Desmos, and so like, it was already confusing for me. Like, that website has always been an obstacle. Like, they weren't talking or interacting at all. So, like, next time, if possible, can I like have a different group?
Yeah, so there is a group with 3. Let me know how this sounds. Let me go ahead and put that in for you because it's just me and you right now in this room. So there's a group with 3. It's there you go. So let me know how does that group sound?
Okay, that sounds great.
All right, perfect. All right, I'll see you
Thank
next time. Bye. Welcome.
Bye. Have a good day.
You too.